Good afternoon, everyone. My name is Christy Ford. I am the account executive at Online Resources and your moderator for today. We would like to welcome everyone to the fourth 3D Lunchbox webinar, Reverse Engineering, A Way into the Future. A special welcome back to those of you who have joined us for previous webinars in the series and those of you who joined us for our deeper dive webinars. Thank you all for joining us today for your lunch, and we appreciate you being here. As a reminder, please do turn on full screen mode for better viewing of the presentations. And in addition, if you have any questions, go ahead and type those in as they come to you. We will do our best to get to those at the end of the presentation. Let's go ahead and get started. Cool. Here with us today, we have a special guest, the man who started it all here at Online Resources, our owner, Jay Schomburg. Jay came right out of college into manufacturing technologies, and in 1991, he had the opportunity to start his own company with the opportunity to work with proven emerging technologies. This year, we are celebrating 30 years with his successful startup. Welcome, Jay.
Thanks, Christy.
We also have JD Schomburg here with us. JD is our Director of Business Development. He's been with the company for the past 8 years and has been a part of 3D data collection for the past 19 years. And last but not least, we have Kate Jacobs. Kate is our Director of Engineering Services. Kate is our resident expert in reverse engineering and GD&T requirements, and he's been with us for the past 5 years. All right. All right, so before we dig into today's showcase, JD, would you mind sharing just a little bit about what Online Resources is all about and what we do here?
Sure. So Christy mentioned that Jay was the founder of the company, and we started in 1991, so this is our 30-year anniversary. We started in CAD/CAM and pretty quickly figured out that we wanted to really dive into all of manufacturing technologies and saw that we had a skill set in the 3D technology side. The difference is we really wanted to prove out this technology and make sure that it was easy and simple to use and to bring in for all of our customers. So that's where we came up with the tagline, 3D technology simplified.
I love it. Thank you, JD. Appreciate that. I think in the interest of time today, we want to move right over into our scanning lab with Jay and Kate to showcase 4 different scanners that show the breadth of options in manufacturing for reverse engineering needs. We are going to start small and work our way up. Jay, can you tell us where we are going to begin and a little bit about why we thought this scanner is a good option for reverse engineering needs?
Sure, I'd be glad to. We're starting out showing the Solutionix D700. It is for small parts. It's very high accuracy, very high resolution. Does an outstanding job on small parts with high detail.
Yeah, as Jay had mentioned, you can see on the side of the boat here, we have very tiny details, the anchor, some of the windows, etc. This, what we're seeing on the screen now, is a merged final product of multiple scans, which are captured in the pre-programmed scanning sequence with the scanner. Like Christy said, we're running a little bit slim on time today, so I wanted to go ahead and jump into the pre-programmed sequence and show you what that looks like. Let me go ahead and hide this merged final version here and start that sequence up right now.
So while you're doing that, I thought just kind of a fun fact about this coin we're looking at today. It is actually a challenge coin. Larry Coleman, our operations manager, actually served on the USS Manitowoc, and that's what's on the coin today. And this ship has served in 3 major confrontations, including Vietnam, Desert Storm, and the Grenada Rescue. So kind of a fun thing to have with us today.
So the Solutionix 700 will take scans, and then the software will fit the scans together. And then as Kate showed, do a final merge model of all those things together.
Right. So in the interest of time, I think I'll go ahead and stop this one. You've seen a few of these scans, and we can move on to something new.
So Christy, we've lost your audio over here. I don't know if you can hear us or not.
My
We'll go-
apologies.
There.
Can you hear me
you're
now?
back.
Great. I was saying that I love the finite details of that scanner, and just, you know, it's great for small parts manufacturing, but as we all know, those parts, they're not going to fit into, not all parts will fit into that scanning environment. So where do we go next?
The next step would be the Handy Scan Black Elite from Creaform. It is a handheld scanner, laser-based, it's blue laser, and it's capable of doing not only small parts, but it can do large parts as well. What we're scanning here is a forging die. It's actually polished, highly polished, it's shiny, and you notice the scanner is able to pick it up with no surface preparation at all. This scanner uses target dots for its positioning accuracy. That's what you see in the background.
Great.
And you see the model as it's created. This scanner is a sub-thousandths accuracy, about 9/10 of a thousandth accuracy. So it's good for a lot of high accuracy work, and the part size can be small to even something as large as a car.
Wow. I love that. So I love the versatility of this scanner, but one thing it doesn't do is color. So what happens if we need color, let's say for, you know, color mapping for artistic purposes? Where do we go for that?
If we need color in the scan, we'll use the Creaform Spark, and we're actually going to do a hot swap now to swap out the Handy Scan for the Creaform Spark. And we'll bring a model that we have here that's fitting with the season, that has some color and texture in it, and we'll do a scan of that.
Are you able to get them to stand?
See if we get that model to hold still.
Let me get the resolution set up here.
So unlike the Handy Scan Black Elite, the Spark does not require target dots. You still can use them if you want for positioning. And it is a white light scanner. We're picking up color, and also it is totally eye safe. So it's a good scanner if we need to scan anatomy or anything else like that.
That's really cool. So he just stopped the scanner, moved around and restarted it, but it doesn't look like you have any dots on there.
Yeah, there's no target dots. This uses geometry for positioning, and yet it's still accurate. We're still talking about a 1.2 thousandths accuracy for that scanner.
It's cool.
That is cool. And look at all the color. We're
Yeah.
seeing, you know, his hair and his eyebrows and his eyes and the scars and even the orange fingernails over there on the hand. I love that. That's great. That has to be incredibly useful even with graphics.
Yeah. Yes. So for being able to replicate the 3D, what we call the texture wrapping image for graphics, AR, VR, marketing type of stuff, that's a really good tool for that.
Yeah, I love that. So we've looked at small parts and we've looked at standardized parts. We've looked at parts that require color.
Yeah.
What we haven't seen is a large part. I think they're getting set up for that for you. But
Yeah.
while they do, why don't you tell us why 3D scanning, why use it in reverse engineering?
Sure. So 3D scanning really creates a framework for you to then build your CAD model step by just Parasolid. So it allows you to create certain entities and then color map and compare how accurate those entities are to each other. And really the short and simple answer is it makes it easier and faster with 3D scanning than going out there with a tape measure and mics and calipers.
I love that short and simple answer. All right, looks like we're getting set up and ready to go here. Let's turn the time back over to Jay as he finishes drying off the car that they've pulled into the scanning lab here. And Jay, can you tell us about what we're going to do here?
We're going to use the Creaform Metroscan for this. As you can see, we've got some rain that's happened, and so I'm trying to get the the water off the car. But the MetraScan is excellent for large parts. It can still do small parts just as well, but does not require target dots and has a cubic foot volume of about 600 cubic feet and is able to maintain an accuracy of about 2/1000 of an inch in that entire 600 cubic foot volume. It's good for scanning parts, cars, small airplanes, and through the addition of photogrammetry, we're able to scan even larger parts than that if needed. But a very versatile scanner.
Very cool. And yeah, it looks, I mean, is that a black or blue?
Yeah,
Shiny
this is
surface?
actually dark blue, but good point. One of the most difficult colors to scan is shiny black, and this does no problem with that. It can also scan highly polished parts, polished molds, even mirror surfaces are no problem for the black MetraScan.
Cool.
Wow, I love that. Well, thank you guys so much for looking at these 3D scanner options. We appreciate you being here today with us and sharing the expertise on those. And we really do appreciate that. I think we're going to change directions here for a second. We are going to talk about software options. I've asked Cade, being our resident expert in reverse engineering here at ORI, can you share your thoughts and give us a quick comparative analysis of software options for reverse engineering?
Sure, Christy, thank you very much. I'm back here in my office now. Hopefully you can see my screen. What's being shown is a software called Geomagic Design X. This is the software that we use most often here in our office for reverse engineering purposes. I've created this model in Geomagic Design X. This is a fully featured standalone CAD modeling package that has any of the modeling operations you would perform in, say, a CATIA or a SolidWorks. The only difference is that you're using scan data as a reference geometry to make sure that you're modeling things accurately. I'll show you here. This is the accuracy analyzer that's within DesignX. This is letting me know whether or not the model that I'm creating is within a tolerance that I wish to hold when modeling the part against the scan data. In addition to DesignX, we also have a software here in-house called VX Model. VX Model, although it's not a standalone CAD modeling package in and of itself, it is a module that's housed within the VX Elements environment. So what that means is you can finish scanning with your Creaform hardware and jump right into VX Model to start creating some reference geometry. I say reference geometry because you aren't creating a beginning to end CAD model that can be output as a step file or a parasolid directly from VX Model. What you're doing in VX Model is you're creating reference entities, reference planes, cross sections, etc., that can then be used and sent to a third-party modeling software like a SolidWorks or a CATIA to create the CAD models there. We have a third reverse engineering option as well. Unfortunately, I don't have it today to show you. Polyworks, a very popular inspection tool called Polyworks Inspector by End of Metric, they have their own modeling suite called Polyworks Modeler. It's very similar to VX Model in that you're creating reference entities to use downstream in a SolidWorks or CATIA. And I would be happy to share information with anybody who's interested in getting some after the webinar, so we'll be in touch.
Thank you, Cade. I really appreciate that. That really is our showcase for today. We would love to hear what questions you might have. You can go ahead and type those in now. It does look like we have a question already ready to go here. Let's see if I can get this. With 3D scanning use for reverse engineering, what issues have you seen and how did you overcome those?
Yeah. With that question, two things come to mind. One is just making sure you have the tool that's appropriate for the job. For example, if you were scanning, say, a a large fixture or something like that, a large gauge. Let's say you're trying to analyze some sheet metal that's being put on an aircraft wing or propeller or something like that, and you have this very, very long inspection fixture. You wouldn't want to use one of the smaller scale systems, say a HandyScan or a GoScan, because those do not operate within a volume and can be prone to error stack up. So you may run into a situation where from one end to the other, the error stack up associated with the scanner exceeds the tolerance you wish to hold on any given model. Additionally, the scanning systems we have to remember are all line of sight, which means that on a part that has some tight geometry, say an engine head with tight ports, you may run into a situation where you need to use the handy probe, say with the Metroscan, to probe some of the minor radii on the inside of a port on an engine head, or we have, and also in the past, sacrificed some of the parts, cut some things up in order to scan water jackets and things of that nature. So just keep in mind these are all line of sight, so you may need to get creative with some of the methods you use to capture the geometry you need to get for the reverse engineering.
Very cool. I kind of had a question on the reverse engineering software. I know you talked about the Designx and the VX model, and then you spoke briefly about the Polyworks. Does like the NCAD package that someone has, like CATIA, what is it, NX, SolidWorks, does that matter?
Not really, unless you wanted to have downstream compatibility with feature trees and things like that. If you're using Designx, you have the ability to model your parts in such a way that you have a downstream compatibility with SolidWorks. So you're using operations while modeling in Designx that SolidWorks understands and can rebuild the model inside of SolidWorks. So you have a full history tree and you can roll things back, change things, etc. So in that sense, yes, because you need to make sure you are modeling in such a way where it will agree with your downstream CAD modeling package. But otherwise, no. I mean, we can also, export generic CAD formats, STEP, Parasolid, etc., which you can import and bring into any CAD system. They're generic and compatible with everything. So
very cool. And then I also have one more question.
Sure.
So we'll let everybody else keep typing in for a moment. So we've talked about the multiple different sizes. What if we have some small parts, some medium parts, some large parts? How do we know which kind of system to go with if we only have the budget for one scanner?
Well, I guess the short answer to that would be you kind of just get an understanding of get an envelope of what you're going to be scanning most of the time. So for a customer that does in the RV industry, for example, they could be scanning anything from the size of a hubcap up to, a front end cap or something like that. Like Jay had mentioned before, the accuracy capabilities of a scanner like the Metroscan is capable of doing something that's as small as the HandyScan in most cases. So for a customer like that, you may want to recommend one of the larger scale systems because, even though the Metroscan is good at scanning small stuff, the HandyScan isn't quite as good as scanning larger stuff unless it's coupled with a photogrammetry system of some sort.
Okay. And that's what you were talking about, large stuff being like 737, Boeing 737.
Yeah, like a front end cap or something like that, like a fiberglass mold in the RV industry or something like that is the first thing that comes to mind. But the world is kind of wide open. I mean, anything that's that size or larger is something that I would recommend the Metroscan for strongly, unless, of course, like I mentioned, you were going to do a photogrammetry system of some sort.
Cool. And then, so we really move through those scanners pretty fast. One of the things that I noticed with the Solutionix, and I couldn't really hear Jay to see if he mentioned this, it was taking multiple like flashes.
Right.
Can you briefly describe what exactly was happening there? Because other systems were just a constant laser and it seemed to just build the model itself when it was scanning.
At their core, they're doing basically the same thing. It's just that the Solutionix is doing it much slower. So the Solutionix is taking a single shot every rotation and then stitching those together with a separate operation after the fact. The Creaform systems are operating at some number of frames per second and are stitching the scans together live. So you don't really see what's happening on the back end, although they're effectively doing the same thing.
Cool. And then we're talking a lot about reverse engineering today. Do you need a different scanner for quality control? Let's say, you're thinking reverse engineering, but also you're thinking a QC application.
Yeah. Any of the scanners that we mentioned today would be adequate for both QC and reverse engineering. With reverse engineering, you have a little bit more flexibility just because you're kind of recreating a part. Things are a bit looser. You have to be a little bit more picky tolerance-wise when you're doing QC. You have to really, really make sure that the scanner's uncertainty does not exceed the tolerances you need to hold on any given inspection. So that's just a conversation we need to have with the specific manufacturer to decide what would work best for them.
Cool. I want to see if questions have popped up.
Yeah. So quick question here. An older part that maybe is not in perfect shape that you need for a reverse engineering purpose, is there a way to reverse engineer it back to the original design?
Yes, we do that all the time here in our office. If you have a die that's been cracked and welded back together, or you have a part that's experienced some sort of wear over time, or you have an exhaust port that's built up some amount of crud over its use. Those are all things that can be accommodated for and built out of the model. So when we do reverse engineering, many times we're doing the reverse engineering to design intent. It's not always. I mean, some people want exactly what we've scanned. That's pretty common as well. But in most cases, a customer that brings in something that's been bent or worn or cracked, they want to make sure things are perfectly parallel, perfectly straight, perfectly square, hole locations in the right locations, things like that. And that's all doable. You just have to make sure that you're being intentional with your modeling and adding constraints where they need to be and things like that. So
cool. And we do have one more question. So we are looking at different scanning systems. We're not sure if we have a budget for it. Is there another option to get a project done?
Another option aside from the purchase of a system, you mean?
I think so, yeah.
Okay. Yeah, so we do service, we do provide the scanning and modeling as a service as well here at Online Resources. That would be one option. We just charge a daily or an hourly rate for those services. Another thing that we've offered in the past, which I don't know, you'd be better to answer this, JD, would be rentals, perhaps. That might be an option. I don't know if that's something that we still do or if that's something that we did limited in the past. But
yeah, the scanners are pretty easy to use from the rental side of things. But typically the rentals are someone who is a current customer and needs maybe the capabilities of a different scanner. So maybe
right.
They have a handy scan and want to borrow or rent the Metra scan. That's kind of the capabilities. Or we go through a training class with them.
Right. Yeah. And that's a good point to add is we do offer training courses with every purchase, and we also offer training courses outside of a purchase if you just wanted to have a training class. If you do have a scanner rental from somewhere, then we can come and teach you how to use the hardware as well, if that's something you'd be interested in doing.
Cool. So we have a couple other questions, but they get into the weeds a little bit on the reverse engineering side of stuff, and I think more of like software, or how do you loft this or do that. Right. So we'll reach out to those people individually, but I think that's all the questions we have for today.
Great, thank you. That's actually all the time we have for today as well, so that worked out perfect. If your question did not get answered, as mentioned, we do have it recorded and one of our experts will be in touch with you within the next couple of days. Thank you all for joining us for the 4th webinar in the 3D Lunchbox series. Thank you, Jay, JD, and Cade for your expertise and presentations today. That's much appreciated. We look forward to seeing you next time for the 5th in the 3D Lunchbox webinar series. where we are showcasing robotics teaching tools. Some really cool stuff planned there with the latest and greatest in robotic teaching tool options with Mark Battisi. And I hear he's even got a new technology he's going to showcase for us. So we're excited.
So we're going to see a product launch here.
We are. It's going to
Cool.
be exciting. As always, if you have additional questions or needs, you can call one of our experts at 765-482-9700 or contact us via email at support@onlineresourcesinc.com. Thank you again and have a great afternoon.